Alright, so I realized that we had some issues with composite functions, so I decided to do a short video. So composite functions. So we said composite functions, we substitute one function into another. So remember when we had things like f of x is equal to 3x plus 1. If we want to calculate f of 3, wherever we say x, we're going to put the value of 3. So in this case, we have 9 plus 1, which is equal to 10. It's a similar concept for composite functions. So let's say we have this function. I'm going to use the example from today. F of x is equal to x squared, and g of x is equal to 3x minus 1. F of x is equal to x squared, g of x is equal to 3x minus 1. And we're supposed to write this as a composite function, fg of x. So what this is saying, we're going to have fg of x. So whatever the value of g of x is, that is what we're going to substitute into our function, which is f of x. So let's start from here. We're going to start from here, and you're going to see we're going to do the same principle that we did up here. So let me write f of x, which is the first step up here. F of x is equal to x squared. Now what we're substituting in f of x up here is 3, but what we're substituting down here is g of x. So we're going to find what the value of g of x is, and we know that g of x is 3x minus 1. So we're going to say f of 3x minus 1 is equal to, so wherever we say x, we're going to put 3x minus 1. 3x minus 1 all squared. And then we know this is the FOIL method. I'm not going to go through the FOIL method here, but you can go through the FOIL method, which is the distributive law, and you're going to see that it's going to be 9x squared minus 6x plus 1. And that should be the answer that you got for today's activity.